Hello students, welcome back in chemistry. Okay, we are discussing chapter number 3, that is electrochemistry. Electrochemistry we have already discussed about nerst equation. Today we discuss about equilibrium constant and nerst equation. Okay, equilibrium constant, that is K. Equilibrium means when reaction in forward direction is equal to reaction in reverse direction. At that stage, equilibrium is attained. In another way, if there is no change in the concentration of reactant and product, then that reaction is at equilibrium. And the K value, that is equal to product upon reactant concentration, that is K value is known as equilibrium constant. How this equilibrium constant is related with the cell reaction and how you can find with the help of nerst equation. That things today we discuss. Okay, suppose we take the cell. Okay, we say the Daniel cell. Zn plus Cu plus 2 gives Zn plus 2 plus Cu solid. For this we will write the nerst equation. Nerst equation is equal to E cell, means cell potential is equal to E0 cell minus 2.303 RT over NF into log anode ion upon cathode ion. Anode ion means it is Zn plus 2 ions upon cathode ion, Cu plus 2 ions. So this is the nerst equation. In this nerst equation, if reaction goes on and on, then after particular time, the reaction will come in equilibrium. At equilibrium, there is no change in the concentration of reactant and product. And the cell potential, this value will turns to 0. Okay, because no electron transfers. So at equilibrium, this E cell is equal to 0. And this E0 cell, for this Daniel cell, means standard potential. If both cells are standard, then its voltage is coming 1.1. That already we have discussed. Okay, anode minus cathode if you do, then voltage is coming. So E cell is equal to 0. You put this 0.0, you write. This is 1.1. Okay, standard potential of the cell minus, if you put R and T value and Farad, then 0.0592 upon N into log. At equilibrium, this value product upon reactant is coming constant. So for this, we can write what it is log K. Therefore, this value 0.0592, if you take on this side upon N, log K is equal to 1.1, or log K, N is coming to, why? Because your electron transfer is coming, so it is 1.1 multiplied by 2 upon 0.0592, okay, at temperature 25 degree STP. If you take R value 0.08314, temperature 25 degree, you convert into Kelvin. Okay, to Kelvin, then it is 298. And put the value, then this value is coming 0.0592. So log K is equal to this. If you want to find the K value, then this anti-log of this value will come. So value will come, K is equal to 2 multiplied by 10 raised to 37. 2 multiplied by 10 raised to 37. So this value will come. Okay. So K value is coming very high for the Daniel cell. From this, if the concentration you change, then K value for different cell will be different. And from this you can find the K value. In last we discussed about how you can relate this K value and cell potential. That I am writing the equation. Okay, from this value, if cell potential is 1.1, But if you take the other cell as compared to Daniel cell, then we can write E cell is equal to, this term will come on other cell, 2.303 RT and F log Kc. So this is the equation related with cell potential, means standard cell potential, and Kc. From this, if Kc is given, then you can find the standard potential, and if standard potential is given for a particular cell, then we can find Kc. Again, from Kc value, if Kc value is high, reactant converted to product very fast. Reaction will be very spontaneous. Redox reaction is spontaneous. If Kc value is less, then reaction is slow. Reaction is going in forward direction, but reaction is slow. Now we take one example related with nerst equation and cell potential. Okay. Example number 3.2. Calculate the equilibrium constant of the following reaction. Reaction is copper when it treated with Ag cell, okay, Ag plus. Then copper is oxidized to Cu plus 2 and Ag plus 1 is reduced to Ag. If you balance the electron, then 2 electron will come. In Ag 1 electron, in copper 2 electrons. So this Ag cell you have to multiply with 2. For this two cell, half cell, copper cell and silver cell, standard cell potential is given, that is 0.46. Okay, from this we will find how to find equilibrium constant. So K you have to find. Okay, first we will write the equation related with cell constant and log K, means equilibrium constant. Okay, E0 cell is equal to 0.0592 by N log Kc. E cell is already given 0.46, which is equal to 0.0592. Here electron transfer, copper to Cu plus 2 means 2 electron. So here N is coming to into log Kc. So log Kc is equal to 0.46 into 2 divided by 0.0592. So log Kc is coming 20, approximate it is coming 15.6. So Kc is equal to antilog of 15.6. So you have to see the antilog of 15.6. So Kc value or equilibrium constant is coming whatever number digit decimal number before decimal, that will come in power. So it is 10 raised to 15. And 0.6 value, it is coming in antilog 3.90. So value is coming. Okay, again I revise. Log Kc is coming 15.6. So Kc is equal to antilog of 15.6. Whatever 15 is coming, okay, before decimal digit will come in power. So it is 10 raised to 15. And 0.6, you check the value of 0.6 antilog. And value is 392 something, 0.6. So we have to put decimal after one digit. So it is 3.92. So Kc value is coming approximate 10 raised to 15. Okay, for the above cell. So in this way you can find equilibrium constant if cell potential is given. Okay, but if the cell is non-standard cell, then for this we have to write the value of concentration. That will, we will not find Kc value, but we will find concentration of reactant and product, and then we can find the cell potential. Okay. Second thing that we discuss is about Gibbs free energy and cell potential. What will be the change in free energy? Okay. According to the law of thermodynamics, if the reaction is spontaneous, then there is always decrease in the free energy. So that we will discuss how this cell potential equilibrium constant is related with the free energy, delta G, that is Gibbs free energy. Okay, electrochemical cell and Gibbs free energy. For that we take the particular cell Zn and copper cell. Zn converted to Zn plus 2, copper plus 2 is converted to copper salt. For that this reaction is spontaneous, then delta G is directly proportional to E cell, means cell potential. Okay, so delta G is equal to minus NF E cell, where N is nothing but number of electron transfer, F that is equal to Faraday, that is equal to 96500 coulomb. Okay, 1 Faraday is equal to 9650 coulomb, and E cell, that is the overall cell potential. If you join the cell, then what will be the final potential, that is equal to E cell. If the cell is standard cell means its concentration is 1 molar. For anode also concentration is 1 molar, and for cathode cell also concentration is 1 molar, and temperature you take 25 degree. Then for that cell we can write E0 cell. So if the cell is standard, then whatever free energy comes, Gibbs free energy, that is also standard. So delta G 0. Delta G 0 is equal to minus NF cell. Again minus sign means if the reaction is spontaneous, then there is decrease in the free energy. Okay, or if free energy decreases, then reaction will take place on its own, means spontaneous. Next, if you relate it with the K value, then delta G is equal to minus RT ln K. Okay, related with K value. Why? Because E cell is related with the K value. So delta G is equal to minus RT ln K. If cell is standard, then instead of ln you can take 2.303 RT log K. So this is equation number 2. Equation number first, delta G is equal to minus NFE0 cell, and delta G is equal to minus 2.303. If you combine this both equation, okay, then you will get the same equation, that is delta or E0 cell is equal to 0.0592 by N log K. Okay, all these value if you put it, Faraday you put it, R value, T value, and this log value, then it is coming 0.0592. So you remember delta G is equal to minus NFE cell, and second is delta G is equal to minus RT ln K. So that is related with electrochemical cell and Gibbs free energy. Sum is given in your textbook. It is simple sum. You have to just put the value and find the value of K value or cell potential. Okay, and exercise sum. So try to solve the Gibbs free energy sum from your textbook and exercise. Okay, thank you.